Hello everybody, we are back with another visual pattern challenge. So here is our visual pattern. We've got all these lightning bolts growing in number. Here's step 1 of the lightning bolts, here's step 2, here's step 3. And your challenge is to use your visual intuition and mathematical abilities to predict the number of lightning bolts in step 4. And then if you can, the number of lightning bolts in step 43. And can you write an equation along the way that would model the number of lightning bolts in any step at all of this pattern? So that's the challenge. If you'd like to give that a try, pause the video. All right, so let's see if we can figure out what's going on just by looking at this pattern. So I've got 3 lightning bolts here. And then in step 2, I've got 2 rows of 3 plus another one. And then I've got in step 3, 3 rows of 3 plus another 2. So I think we could predict in step number 4, right? I would have 4 rows of 3 lightning bolts. So let's make 4 rows of 3 lightning bolts. Okay, plus another 3. That would seem to mimic the pattern. How many would that be total? So 4 times 2 is 12, 13, 14, 15. So this would be 15 in step number 4. So that's our prediction. I think what I want to do is analyze the numbers because this pattern, the way it's laid out, is a little confusing to me. So I want to analyze the numbers and take a look mathematically at what kind of pattern we're dealing with. So I'm going to make a chart with the step number and then the number of lightning bolts in each step. So in step 1, there are 3. In step 2, we've got 7. In step 3, we've got 9, 10, 11. And in step 4, we're saying there are 15. So once we've got all these numbers listed out, what we usually do is take the differences. So 7 minus 3 is 4, 11 minus 7 is 4, and 15 minus 11 is 4. Aha. So when the difference in each step is a constant number, this means it's going up by 4 bolts every time. We're adding a row of 3 plus another one, so I guess that makes sense that we're adding 4 every time. When this number is constant, you know that the pattern is linear, and you can use the equation for a line to model it. So we'll start with y equals mx plus b, this equation for a line, and m, which stands for the slope when you're graphing a line, this is the rate of change, the rate of growth of our pattern. So the m will be replaced by this 4. X represents the step number, and then this plus b is whatever number we need to use to adjust it so that it works with what's actually in the pattern. So let's try y equals 4x, and I would plug in 1 for x in step number 1, and that would be 4 times 1 is 4, but we've got 3 lightning bolts. So this is 1 too many. To adjust that then, my b can be a -1, so I can just subtract 1 from that. And our equation down here then would be 4x minus 1. So that's what I think the equation is. Let's test it with a couple of other steps just to double check. So y equals 4 times step 2 minus 1. 4 times 2 is 8 minus 1 is 7. And yeah, there are 7 here. How about step 3? Y equals 4 times step 3 minus 1. 4 times 3 is 12, minus 1 is 11. Yes, that is how many lightning bolts there are in step 3, 11. Great, so we've got an equation that works. I'm going to jot it down here, y equals 4x minus 1. Now we can use that equation to calculate the number of lightning bolts in step 43. So y equals 4 times step 43 minus 1. So let's see, 4 times 43. 4 times 40 is 160, and 4 times 3 is 12. So that's 172 minus 1. So that's 171 lightning bolts in step 43. Well, how did that go for you? Did you get 15? Did you get 171? Let me know. Thanks, everybody.